Hello everyone, welcome back to Cambridge Guru. We have already started with the new chapter differential equations, and in the previous video it was about forming a differential equation, and I gave you the introduction at what is exactly a differential equation, right? And then we form using some example we form certain differential equation. This video is about once we will form a differential equation, then how to solve those differential equations. As far as your syllabus is concerned, although there are various ways to solve a differential equation, but in our syllabus we have just separation of variables. Means only one method is in our syllabus, and it's a very short chapter and very easy. Easy in the sense that once you are able to form a differential equation, and it is very easy to solve this since there is only a one method, as I said. So let us start quickly with the illustration that is in front of you. We have to solve this differential equation, which is dy by dx is equal to 3x squared minus 2. As I said, that there is a method which is called a separation of variables. So as the name suggests, that we have to separate the variables. As you can see that there are two variables in this differential equation. One is dy, one is y, and one is x. And by the rules of integration, that we know that if there is a variable y, then that will be integrated only with respect to y only, right? And similarly, if there is an x variable, then that will be integrated with respect to x only. Meaning is mathematically that we should form or adjust these variables in such a way that the terms or any function which involves x, right? All the terms which involves x may be regarded as a function of x, and those should be combined with the this differential variable which is dx, and then only you can integrate this, right? Similarly, there must be a y variable dy, and the term which contains the y variable is regarded as fy, then only you can integrate, right? And if you are able to, as you can see here, that the variables have been separated, that all the x terms which I am calling as the function fx, they are with dx, and the function or the terms which involves y, they are with dy, and then integrating this you will get the solution of the differential equation. That is the meaning of solving a differential equation. So if you have to solve this, the given you can say the equation which is written as dy by dx. So what I can do is that I can transfer this dx to the term 3x square minus 2, and I can regard this 3x square minus 2 as a function which involves the x variable, right? You might be saying that what about this 2, because it does not contain x. Then there is no issue with this. I can show you that it contains an x, that I can write this as just x raised to power 0, right? So this a constant also can be integrated either with respect to y or x, right? But I cannot transfer this minus 2 to LHS, because then you cannot associate this 2 with the variable either dy or dx. Okay, so let us keep this 3x square minus 2 in the right hand side only, and just transfer this dx to RHS. So when I do this, you will get dy is equal to 3x square minus 2 into dx, right? Now I have separated the variables, right? I can integrate this. So integrate this dy, as you can see there is no y here, but yes, there is a constant which is 1, which is in the multiplication of dy. So I can integrate this. I will get y is equal to 3x cube over 3, because RHS will be integrated with respect to x. So I will get 3x cube over 3 minus 2x. Okay, and there is always a constant of integration c. Okay, I can cancel this 3 with this 3. So final equation I will get as y is equal to x cube minus 2x plus c. This is the solution of differential equation. Meaning of this solution is that your original function is y is equal to x cube minus 2x plus some constant. If you differentiate this, you will get the differential coefficient dy by dx as 3x square minus 2. That is the meaning of solving a differential equation. Okay, we have been given the differential equation, and solving the differential equation means what derivative or which function is it that we have to find out whose derivative is given. We have to find out the function whose derivative is given in the question. That is the meaning of solving the differential equation. Now, there are two types of solution. One is called the general solution and one is called the particular solution. General solution means that I can take the c as any value, any constant, right? It could be +1, it could be +2, 3, -5, pi, e, any constant you can add for this c value, right? And you will get different types of functions, right? But once you differentiate this, the differential equation you will get, which was given in the original question, which is dy by dx equals 3x square minus 2, because the derivative of the constant is always 0, right? So this is called the general solution, that we do not know the exact value of this constant, right? So what is the particular solution? Particular solution is that for a particular value of x and y, you will get a particular solution, right? A particular function whose derivative is given, right? For example, that if you consider that there is a point, let us say 0, 2, which is lying on the curve. This is the condition given, that there is a point 0, 2, which is lying on the curve, right? So that means the value of x is 0 and value of y is 2, because if this point is lying on the curve, let us say this is the curve, right? So x comma 0, not this, let us say this. Okay, so x is, let me remove this, just a second. Yes, so let us say we have been given a curve 0 comma 2 like this. Okay, so this is a point 0 comma 2 which is lying on the curve, right? So I can satisfy the given equation, the given function with this point 0 comma 2. So value of y is 0 at x equal to 0 plus c. So here I will get c as 2. So putting this value back into the equation, I will get y is equal to x cube minus 2x plus 2, right? So using this condition that y is equal to 2 at x equal to 0, so you are giving a particular curve, that at a particular curve, these are the conditions that are satisfied. Okay, so from there I will get the value of c as 2. So this is called the particular solution, that this c value, which is 2, is only possible for a particular curve, which is x cube minus 2x plus 2. Okay, if I do not know the value of this constant, I will say that it is just a general solution. That's why the name it is given. That's why the name is given as general. Let us take another example. Find for y greater than 0 the general solution of the differential equation. Remember, it says the general solution means there is no condition given of the differential equation this. So again, separation of variables. So what I can do is dy by dx is equal to xy. So what I can do is I can transfer this dx to RHS and bringing y in the denominator of dy, means again separation of variables. So if I do this, I will get dy over y is equal to x into dx. Variables have been separated. Now integrate this, you will get ln y. Since y is positive, there is no need to use the modulus sign in this y, because it is given that y is positive. So it is ln y is equal to x square over 2 plus c. And this is the general solution. Okay, it's very simple. Let us take another example. Now, this is just a repetition of what we have done in the previous video, where we were forming the differential equation, right? So now you will get some question where you have to form the equation and then you have to solve the differential equation by using some initial conditions, if they are given at all. Okay, so it says that the acceleration of an object is inversely proportional to its velocity at any given time, and the direction of motion is taken to be positive. So it says that there is an acceleration a, let us denote acceleration by a, and it is saying it is inversely proportional to the velocity. So this is the sign of proportionality. It is equal to, or not equal to, it is proportional to 1 upon v, right? If I remove this, so I will get a is equal to, by using the constant of proportionality denoted by k. Okay, so it is k by v. Fine. So it said that when the velocity is 1 meter per second, acceleration is 3. Using these values, I have to find out this constant of proportionality. So a value is 3, This is k and v value is 1. So here I get value of k as 3. Putting this back into the equation, I get my equation as a is equal to 3 over b. Then it says that find a differential equation to model this situation. What do you mean by that model this situation means at a particular instant it is given that if the value of velocity is 1, then acceleration is a. But in the question it says that the acceleration is inversely proportional, means as the value of velocity is increasing or decreasing, acceleration is also changing. So acceleration is not constant. That means this is changing with respect to velocity. Okay, so having said having said this, you must be knowing that I can replace the variable expression a as d with dv by dt. Okay, because v can be denoted or can be written as ds by dt. Rate of change of distance is velocity and rate of change of velocity is acceleration. So instead of writing this a, because I have to form a differential equation, so differential coefficient must be used as a variable, right? So a has to be written by or replaced by dv by dt, showing that this acceleration is not constant, it is changing. Okay, this is equal to 3 over v, right? So first part answer is this, that differential equation is dv by dt is equal to 3 by v. And the second part it says find the particular solution. So remember, particular solution means we have to find out the value of integration, constant of integration after integrating or after solving this differential equation. So first step in doing the second part is we have to solve this differential equation by using obviously the separation of variables. If I separate the variable, I will get v dv, transferring this v to LHS and dt to RHS like this, 3 dt, and then integrating this. If I integrate this, I will get the integration value as v square over 2 is equal to 3 times t plus there is a constant of integration. Now initial condition means this is the general solution, but it is asking for the particular solution. So obviously there must be some initial condition that initially the velocity is 2 meter per second. Now what do you mean by initially means at the moment that you have started measuring the situation or observing the situation, it is not necessary that at t equal to 0 velocity has to be 0, right? You might be thinking that if t is equal to 0, how can the velocity would be 2, right? So it doesn't mean that the object or the object or the velocity of the object has to be 0. It is not necessary that object has to be at the rest initially. Okay, it only depends at the instant you have started measuring the situation. Okay, so at t equal to 0 it says that velocity is 2. Initially means the time where you have started measuring. Okay, so t is equal to 0, v is 2. So 2 square over 2 is equal to 3 into 0 plus c. Here I will get value of c as 2. Putting this into the equation back, I will get v square over 2 is equal to 3t plus 2. Okay, this is the solution or the particular solution of this situation. Okay, now it says that in this case, third part, how long does the object take to reach a velocity of 8 meter per second? Now this time, since I have now the relation between velocity and time, I have to find out the velocity when t is not the velocity but time we have to find out, right? Velocity is 8. Okay, so putting this value of 8, third part equation is v square over 2 is equal to 3t plus 2, putting the value of v as 8. So 8 into 8 is 64 over 2 is equal to 3t plus 2. That means this is 32 minus 2 is 30. So 30 is 3t. That means t is 10 seconds. Please do not forget to look once again the units, whether the velocity is in kilometers per hour or meters per second. All the units, this was a standard unit meter per second, so obviously t has to be given in seconds. Okay, that's all for this video. I will come back with the next video in which we will solve some more complex differential equation where other methods of integrations will be used. Okay. Till then, bye bye. Take care. If you have any comments, if you want any other, any problem in this differential equation or any other topic, just write in the comment section. I will get back to you. Okay. Bye bye. Take care. I hope you enjoyed this video. See you soon.